Chapter 6, Bending, Part A, Centroid Concept, Example 2. Centroid example 2, just consider we have a cylinder, a solid cylinder, and we want to take a conical shape out from the cylinder, and then we want to know what the this then what is the y component of centroid. Mhm. If we just have a cylinder and we want to take out this conical shape from our cylinder, then we want to know what is the overall y component of the centroid. Let's see how we can approach this problem. Let's first consider our cylinder. So the centroid of cylinder from any end. For example, if you consider this part, the x-axis, then z bar is just a half of the height due to symmetry of the shape. And then, so we are doing uh, each centroid separately, then subtract them from each other to get the overall centroid. So if you have one shape subtracted, so if we want to take out a conical shape from the cylinder, at the same time we have to subtract the centroid based on the centroid for discrete part come along together. So this is the centroid for the cylinder one, and the other component is the calculation of a centroid of a cone. So let's see how we can handle this part. So if you just assume an area like this, and if you sweep this up and down to cover the whole cone, it can gives you the centroid for a cone from any base, for example from x. Mhm. Based on the solution for formula for centroid, we do know z bar. If you are working with a 3D shape, just go for dv and dv. If it's for a 1D, just go for dl, and if it's for 2D, just go for the area. So the element of the integration of element of dv, which is the volume of a cone, which is a 1/3 of the same cylinder, and that's integration at the numerator z tilde times dv. Mhm. So let's develop our relation x, our diameter for this area, for our element, based on our r in comparison to the whole radius is z in comparison to the whole a diameter of whole uh, height of h of the cone and cylinder. They have the same height, so it gives us a zx based on z and r, and at the same time we do know our dv, the element of our the volume of our element, which is almost here. Let's have it by, for example, this is the volume of our element, so that's a z from z tilde, that's here, and then pi x squared dz. This is pi x squared. Mhm. And just by replacing the x from here, so just replace it in the main formula, then it gives us a z times pi x squared r squared over h squared times z squared times dz, which is here. Mhm. Over the, again, volume of a cone is a 1/3 of the same height of cylinder. So if it was the whole cylinder, from the top to the bottom, the area was pi r squared h. The area of cone inside a cylinder with the same height is a 1/3 of pi r squared h. It means you can have three cone inside a cylinder with the same height. If you do the math, it gives you a, let's make a bit cleaner. If you do the math, it gives you z bar is equal to a 3/4 of h from x-axis. So one can say 1/3 from the base, sorry, 1/4 from the h, 1/4 from the base of the cone, or 3/4 from our arbitrary base, which is x-axis. As soon as we do know the centroid for the cylinder itself, which is h over 2, and we do know the centroid of a cone with the same height, which is a 3/4 of h from our base. So let's combine it together. As soon as we subtract these two from each other, we can get the centroid. If you so one can say z bar for a cone is a 3/4 of h from x-axis, or z bar is a quarter of h from the base of the cone. Let's back to our problem, which just says z bar is in the case you have different part, it's summation of z bar dv over summation of volume. And when you are subtracting them, that's simple enough. You have to subtract them from each other. So this is h bar, which is the z4 for, so this part belongs to cylinder. This part belongs to the cone with the same height, volume of cylinder, and then volume of cone. Subtract from each other. So that's a half of h for the cylinder itself times pi r squared h, which is the volume of cylinder, minus, we just calculate the z for a cone is 3 over h from the x-axis. If this is x, then times a 1/3 pi r squared h, which is the volume of cone, over the subtraction of volume of cylinder minus volume of the cone. And if you do the math, it gives you, let's make it a bit cleaner. It gives you z bar is a force of pi r squared h squared over 2/3 of pi r squared h, which if you cancel out one of the h with h at denominator and r squared with r squared, it just pi with pi, it just gives you 3 over 8 of height. And then z bar for our problem is 3 of 8 of the total height. If this is our this is our total height for the combined, and this is the radius for cylinder and cone. Thank you.